Thank you. So that's basically it for types of blockchain. We shouldn't waste more time on it. Now let's look at the generations of blockchain technology. Of course, the generations will show us how blockchain technology has evolved or how it is evolving, because it is still evolving. I believe blockchain technology still has a long way to go, and I'm dedicating my whole life to work on blockchain technology. So it's amazing. Now, generation of blockchain technology, according to six is referenced down the slide. We have we currently have three generations of the blockchain. Of course, it is June 17th, 2021. So we currently have three generations of the blockchain. Generation 1, Generation 2, and Generation 3. So Generation 1 blockchain basically covers the Bitcoin and some other blockchain projects that immediately followed it. Okay, so Generation 1 blockchain is basically, when we talk about Generation 1 blockchain, we're basically referring to the Bitcoin and other blockchain projects that followed it. Now, this is not to say that the blockchain has not been around before 2008, when Nakamoto Satoshi invented the Bitcoin. So of course, when I say Generation 1 blockchain, it's not saying that is exactly when the blockchain or when the old blockchain concept started, because we have records in history of a lot of things being done on the blockchain, concepts that are relating to the blockchain. In fact, things around the blockchain that are actually have been said long ago before then. Okay, so but let's see. But it points to the fact that the blockchain is the first real use case of the Bitcoin is the first real use case of the blockchain technology. So when we say Generation 1 blockchain, I'm giving an example of things like the Bitcoin. It does not mean it was until Bitcoin was created that blockchain existed. But like the Bitcoin is the first real use case of the blockchain. So we really see it as part of Generation 1 blockchain. Okay, so whatever other blockchain projects around that time, including the Bitcoin and the rest, are all grouped together as Generation 1 blockchain. And most of the characteristics of this blockchain is basically they're characterized by their use as digital currencies. So most of them are almost all Generation 1 blockchain are driven as used for digital currency. Of course, I'm not saying not all blockchain technology that is used as digital currency is Generation 1. Okay? But I'm saying most of Generation 1 projects be aimed at to be used as digital currencies. I could be wrong, but this is all based on my scope of knowledge. Okay? If I'm wrong, you can also leave it down as a comment if you are watching on YouTube. If I'm wrong and you're a student, you can also do well to tell me no. Let me know in class or message me on WhatsApp. Okay, I could be very wrong. This is based on my knowledge, but most of Generation 1 projects, at least for my research and the rest, were all related to things around finance, things around money, okay, things around digital currencies and the rest. Generation 2 blockchain. Now, the second generation of blockchain kickstarted when it was thought of that the blockchain could be used for more than just digital currencies or simple document transaction. That the blockchain could do things beyond just money. Okay, the title of the chapter. So it was considered that the blockchain can be beyond just money, beyond just digital currencies. And we see that the Ethereum project was one of the first project to start from here. Okay, the founders of Ethereum had the idea that assets and trust agreements could also benefit from the blockchain technology, and this led to the creation of smart contracts, or preferably the awakening of smart contracts, since they are actually said to have been proposed in 1994 by Nick Szabo, an American computer scientist. Of course, again, just trying to say the same thing. Generation 2 blockchain is this generation of blockchain where people begin to see the use of the blockchain technology beyond just money. Nakamoto Satoshi invented the Bitcoin and was able to solve a typical problem that money has. Can we expand these properties with which he used to solve this problem to other fields of life, to healthcare, to election voting, to legal issues, to land purchasing, to music auditions, to artwork sales, and to can we extend it to every aspect of life? This is the same idea. So can we go beyond just money? So this is where the second generation of blockchain begin to come in. And one of the key elements of the second generation blockchain, one of the key things is the idea of smart contract. Okay, smart contract. Of course, this doesn't mean smart contracts started with generation 2 blockchain technologies. Of course, like I said in the slide, it has already been, it's said to have been mentioned already, or to be proposed by Nick Szabo, a 1994 computer scientist, American computer scientist. So now, when we say smart contract, basically what do we mean? This crazy thing that seems to lead us to generation 2 blockchain. What do we mean? It's according to 5, okay, a smart contract is a self-executing contract with the terms of agreement between both parties involved in the contract being directly written into lines of code. Okay. Now, the idea is we have parties, and usually parties come together in agreement in a contract. So a smart contract is where the terms of the agreement are written as line of code, clearly defined as line of code. If this condition A meets this condition B, then give us condition C. Garbage in, garbage out. So that's basically it. So the idea is the simple idea of smart contract. Since we're going to be working more with smart contracts a lot, I wouldn't want to delve deep into it. We're going to have the chapter 2, which is going to be centered a lot around smart contracts. I mean, I said chapter 2, the book 2, the part 2 of this whole class, because this is just the introductory class, running us through a lot of things about the blockchain. Then when we get to the part of smart contract, we'll look so deep. But the idea of smart contract is, imagine you are trying to have a contract with someone, but the contract deal is now placed there on the blockchain, written in lines of code. And it's a smart contract that enables us to, in fact, remove the middleman. Because I have a contract, and I put in my 100,000, you put in your 100,000, like the example we gave of 2 guys betting. You put in your 100,000, I put in my 100,000. The algorithm knows that whoever wins, the algorithm monitors the winning process. Whoever wins gets the money at the end of everything. Algorithm does it without any middleman. So smart contract is basically a self-executing contract that has been written as line of code. Alright, we'll get back to a lot into smart contracts when we get to the part 2. Okay, now the code and agreement contained therein are also distributed across a blockchain network. So this is the powerful thing. The agreement is not just on one server or one computer or on a small, on a server or computer somewhere. It is distributed using the blockchain. Of course, it takes all the properties of the blockchain, being immutable, being decentralized, because it's going to be distributed, and being transparent. So it's going to be crazy and amazing. The code controls the execution, and the transactions are traceable and irreversible. Of course, traceable in the sense that you can see them and they cannot be reversed. Once the term of agreement has been made, I can't say, I'm sorry, I want to change, No. The agreement has been done, that's been put on the smart contract. Are you sure you want to agree to this? You agree to this, then you are in for it. So smart contracts, gets everything done. 5 goes further to say that smart contracts permit trusted transaction and agreement to be carried out among disparate anonymous parties without the need for a central authority, legal system, or external enforcement mechanism. Because this is one of the key use cases of the blockchain. I don't need to trust you, I don't need the middleman, I don't need the bank, I don't need the lawyer. We agree, we put it on a smart contract, and everything is done. Alright, so let's see the challenges of generation 1 and 2 blockchain technologies. We're going to see this, and then we're going to see generation 3. Now, generation 1 and 2 blockchains, they have some very key challenges, some of which include number 1, scalability. Of course, don't forget, this part of the course is just like a summary of everything around the blockchain, just a summary of some of the key things I think you should know before we dive deeper into the blockchain. So, generation 1 and 2 blockchains have some challenges, and one of the key challenges they have is scalability. Now, scalability itself, basically, according to what I have here in the slide, and according to what is true, scalability itself has 3 parts. Okay, when we talk of scalability, it usually refers to 3 key things. First is transaction per second. I'm trying to write on the board. Transactions per second. The second is what I have here, network bandwidth. And the third is storage. Of course, when I say generation 1 blockchain, you know I'm talking of the Bitcoin, majorly the Bitcoin. When I say generation 2 blockchain, you know I'm talking of Ethereum. So currently, Bitcoin and Ethereum have some problems. Which one of them is scalability? And when we talk of scalability, scalability itself refers to three core things, which is transaction per second, network bandwidth, and storage. So transaction per second, of course, with the whole proof of work mechanism that the Bitcoin blockchain is using, you can see it is not so easy for the computers to be able to solve that problem so fast. In fact, on an average, it is said that it takes 10 minutes for a Bitcoin block to be mined. On an average, 10 minutes. So, doing extrapolation and a lot of other things, based on the amount of transactions that can be in a block, it is discovered that it will take about, Bitcoin network can undo 4.6 transactions in a second. Now, again, I think I need to make this clear here. Remember I said it takes 10 minutes to mine a block. But remember, a block is holding a data set. So it's not as if a transaction is what is in a block. In a block, we can have more than one transaction. In fact, on an average, Bitcoin can take 2,759.15 transactions in one block. Okay? So a block is like it groups the data set and gives them one particular ID. You know the whole thing we explained. So what I'm just trying to make clear is, I use the Jane and James example on a very, very simple level. So but for this statement, not to contradict myself, I need to quickly explain it to you. But as we go deeper, we'll really see it. So it's not as if when Jane and James do that single transaction between Jane and James that we saw in chapter 1, it's not as if that transaction is itself a block. No. Okay? So there is a block. Whenever a computer creates a new block, it can put in, the block has a size, an amount of transaction that can take. So any other subsequent transaction, that computer will be the one to put it into the block. So the block can take about 2,759.15 transactions. So doing this calculation based on the time, we broke it down that we can undo around 4.6 transactions per second. Of course, I think this is 10 minutes, 60 seconds in a minute. That will be 600 seconds. When we divide it by 600 perhaps we might be able to get this. So we could have 4.6 transactions per second on the Bitcoin network, and this is super slow. Just imagine big businesses, big companies are trying to adopt the Bitcoin for transaction. It's going to be crazy because big businesses, just imagine a bank, thousands of transactions are going on at the same time. Hundreds of transactions. People are sending money. As I'm sending, trying to make a transaction on the first bank, another person trying to make transaction using first bank, another person trying to make transaction using first bank. A lot of them. So, but blockchain network can only do 4.6 per second, which is, let's just say 4 per second, which is really, really crazy and really, really small. So this is a very big problem the blockchain network is facing. If it's to get that huge adoption of a lot of businesses using it, it could get a little slow. Okay? And transactions can start piling up. Just imagine in a second we have about 1,000 people. Of course, 1,000 is too small. In Nigeria alone, we have about 200 million people. Out of those 200 million people, it is not out of place to say 1,000 people are trying to do a transaction per second. It is not out of place of 200 million people. 1,000 is so small. I mean, 1,000. Let's say how many 1,000 do we have in 200 times 10 raised per 6? It's crazy. This is just 1 times 10 raised per 3. 10 raised per 3 times per 3. This is 10 raised per 3. You can do this fraction. It's so tiny. So you get, so it is not out of place to say 1,000 people. So imagine 1,000 people are trying to do this transaction at a time, and Bitcoin can only take 4.6 transactions per second. Then that transaction is going to, some of those transactions will have to queue to the next next second. And in that next second, another set of people are doing transaction. It has to queue. Another set of people are doing transaction in that next second. So before you know, the network is queuing and it's taking days for people's transaction to be processed. So Bitcoin network has this problem, and Ethereum also has the same problem. In fact, currently it is said that Ethereum on an average can process 20 transactions per second. Of course, which is not too good enough, because imagine the whole world. Let's say I don't know, let's say we have 7 billion people in the world. I don't know the current population with the whole coronavirus thing and all that. But let's say we have 7 billion people in the world, or let's scale it down to 5 billion people in the world. Out of 5 billion people in the world, let's say 100 million people are trying to do this transaction at a time, and Bitcoin network can only 1 billion of everybody in the world decides to use Ethereum for transaction, if Ethereum gains massive adoption, out of the 1 billion using Ethereum, let's say in a second, 1,000 of the 1 billion are trying to do transaction, and Ethereum can only take 20 per second, and the next second another 1,000 is trying to do. I mean, it's just so crazy, because this thing doesn't happen exactly like this, but I think it's not out of place to assume 1,000 per second out of 1 billion people. 1 billion people. So, and Ethereum can only do 20,000 per second, which means things will pile up, and at some point, some transaction will start taking days, months, and as it goes, years. So Ethereum also has this transaction per second problem. So the idea is, if the blockchain is going to gain the adoption we say it should gain, they have to work on this and make there to be enough transaction per seconds. I mean, enough transaction per second, because currently we have the MasterCard can process up to 5,000 transactions per second, which is a household company. People are already using this for business. Businesses have already adopted it. You can take up to 5,000 transactions per second, so you can do transaction and you don't really feel it lagging. If the blockchain is going to gain this massive adoption, this mass adoption that we are really looking at, they have to really work on transaction per second. Alright, of course, this again has been solved. This at least to an extent has been solved, or has proposals to make it solved. When we get to generation 3, we're going to see this. Blockchain is amazing. Alright, so the next thing is network bandwidth. So the problem with network bandwidth is, we call that on the Bitcoin blockchain, we say this is a peer-to-peer network thing. Okay, and so once a computer puts a transaction inside a block or mines a block, it has the record and it broadcasts this record to every other computer connected to the node. So if successfully we are able to handle this transaction per second problem and get it up to like 1,000 or 2,000 transactions per second, it means all the computers connected to the node have to be downloading about 2,000 transaction record of information in a second. Every single computer on the network. I mean, this can be very, very crazy and can cause some computers to lag beyond others, because not all computers will be able to do this so fast. Apparently, we're ready to scale to tens of thousands of transactions per second. So of course there will be a network bandwidth problem here. So of course, because we need a very large bandwidth to be able to download this data. Each of these networks will need a large bandwidth to be able to download this record and keep on their own data, their own local storage system. Because of course the idea of blockchain is this record is distributed across different computers. So if thousands of transactions are happening per second, that means each computer has to keep downloading thousands of records per second. This is crazy. Okay? So, but we have to really work on this network bandwidth problem also. And there are proposals to work on it in generation 3 blockchain. The other thing is storage. Remember, we said the blockchain is meant to be immutable. Okay? Meaning the records of the files cannot be tampered with. They cannot be deleted, they cannot be updated, nothing can happen to them. So, if the blockchain gains massive adoption, let's assume currently we have 5 billion people in the world. I mean, let's say after COVID and a lot of things, let's say we have 5 billion people in the world. This is very wrong, I'm sure of, but let's just put it at that level. So let's say out of the 5 billion, about 1 billion, I mean, massive adoption of the blockchain, about 1 billion start doing things on the blockchain, businesses on the blockchain, software on the blockchain. They start using what we call decentralized applications, dApps and the rest, and all that. So you can imagine all this record of data in about 100 years time or 50 years time, the storage space is going to be a crazy problem. So this is one of these, the first and second generation blockchain really need to upgrade on. Okay, so that's what we'll talk about, scalability. Of course, scalability, from that word, it means the ability to expand, to enlarge. The first generation blockchain and second generation blockchain have solved some key problems. Okay, but let's now look at expansion from where we are now. Gaining mass adoption. Transaction per second is currently low. Network bandwidth is a big problem, and of course storage would be a big problem. Okay, if we gain this massive adoption we dream of. So these are the scalability problems of the first and second generation blockchain. The second major challenge is interoperability. Now, 7 defines 7. Of course, 7 is referenced down in the material. So 7 defines interoperability as the ability of 2 or more software components to cooperate despite differences in language, interface, and execution platforms. Okay, basically, what is this talking about? The ability of two or more software components to be able to cooperate despite some differences is what we call interoperability. Currently, we have a lot of blockchain projects. A lot of blockchain projects. We have, of course, we know the Bitcoin, we know Ethereum, we have the Binance, we have Cardano, we have Polkadot, we have Solana, we have Avalanche, we have so many. I mean, we have Sushi, we have Uni, we have a lot of blockchain projects. But one crazy thing about this project is most of them do not talk to each other, do not connect with each other. So AMP might be solving a particular problem, Avalanche is solving a particular problem, and Polkadot is trying to solve a particular problem. And it gets to a point where Polkadot, we would need to do something that Avalanche is already doing. So what, of course, what is the best thing? The best thing to do is for Polkadot to communicate with Avalanche, interface with Avalanche, getting the functionalities from Avalanche and be able to do that thing, instead of Polkadot having to create his own version of that thing, which will take a lot of time. So that problem is still there with Generation 1 and Generation 2 blockchain. So despite the fact that the project has solved the problem, another blockchain project that is doing something else that needs that functionality cannot just connect with the other project that has already solved that problem. Okay, usually most of the time we have to now build its own again from scratch, which is time consuming. And of course, because we all know as humans, nobody can be no single person can be an island. Okay, no single tree can be a forest. So no matter how much a project tries to do a lot of things, it gets to a point where it will not be scalable, it will not be fast enough, it will not be growing enough. So the beautiful thing is there are a lot of people doing different things. Let everybody all do different things. When I need one of the functionality that you have already done, I just tap into it instead of creating my own. In that way, the whole blockchain ecosystem is going to be mad and crazy, and it's going to be able to advance and scale faster because you've already solved this problem. I don't need to solve it again. I just tap into your network and be able to use that functionality. So the blockchain, but Generation 1 and Generation 2 currently have that interoperability problem. They are doing good, but somebody else has solved the problem. They can't communicate to tap the solution. They are not communicating with each other. So if we look at if being able to solve this problem, I mean, will be a big milestone breakthrough. Okay, it will be a very big breakthrough. And Generation 3 blockchain are working on that. Then the other thing is sustainability. This is another big challenge. Of course, most of the blockchain projects we have now, because they've not really gone to mainstream adoption as such, most of them, the ways they raise funds, okay, for their projects, usually at some point, the major way was to do ICOs, to have what is called ICOs. Okay, with these ICOs, they're able to raise some money for the project. Okay, but now the problem is this: perhaps not even up to 25% way into the project, the funds they raise from ICOs have perhaps been exhausted. So then, how do they go continue with the project? So a lot of them just crumble, trying to raise funds. Perhaps they've not even gained so much awareness already, and maybe some people they've not been able to get a lot of investors to believe in them. That project, though it's amazing, is just going to die. So sustainability has been a very big problem. This project is mad, it's crazy. I mean, on the blockchain, funding is a very, very big problem because these guys are trying to do something that is a little out of the box. There are a lot of things you'll be checking on the blockchain and we are going to see what blockchain guys are daring to do. This thing might look almost impossible, almost crazy, almost risky. You begin to wonder, is this even possible? But they are daring to do it because they've thought of it. And something about us as humans is when we think something, we are most likely going to do it. So look what I'm saying, come on, can these guys do this thing? Can these blockchain guys do this thing? But the beautiful thing is, I believe nothing is impossible. Okay? With the help of God, nothing is impossible. So these guys have a lot of plans, but at some point they get stuck due to funding. And so because they don't have so much funding to keep the project running, a very good part of the project starts suffering. And of course, we know how investors are these days. They are not, a lot of investors are not really in for very, very long term thing. They just want to get gains. That's what investors are interested in, which is good, which is right, and which is just, since their money is involved. So it takes a lot of faith investing in blockchains these days, and halfway, most of them cannot sustain the project anymore. So, but these are part of challenges generation 1 and generation 2 blockchains are having. In fact, I think Ethereum had this problem at some point because Ethereum is really crazy. I really see Ethereum as I don't know, the new internet. It's really crazy, and because of the idea is so crazy and so amazing, and what they want to do is so much. I mean, they had this great vibe at the beginning, but at some point, I think they were running out of funds. But thank God, one way or the other, they were able to escape. And if not for Ethereum, perhaps I would not even be dreaming of the blockchain, because Ethereum has a lot of weight, has changed my life. And one of that strong project that's really changing my life now is the Binance Smart Chain. Anyway, we look at all these things, but sustainability has been a very big problem, but they are working on solving that issue. In fact, Cardano has provided the solution to that. Now, the other problem is energy consumption, and this is one of the craziest problem. If you are here in 2021, I mean, you can see what has happened with Elon Musk tweet. There was a time Elon Musk tweeted that Bitcoin is consuming so much energy and causing environmental pollution and all that. So we are going to look at that now. So remember the Bitcoin, in the Bitcoin network, do you remember the consensus algorithm the Bitcoin network uses? Remember, we covered this in the last class. Do you remember? Tell me. Think. Alright, yeah, you got it. Proof of work. So the Bitcoin network uses the proof of work consensus algorithm. And if you remember, in the proof of work consensus algorithm, all the computers on the network are racing. They are competing to solve this problem. The computer that solves it first gets the reward, isn't it? So, but in the process of all the computers trying to solve this problem, all these computers are expending energy. Remember, I talked about something called the difficulty level. Once the Bitcoin network senses that it's very powerful computers enter the network, it raises the difficulty level of the problem. So the problem becomes harder and harder to solve as more and more people join in the Bitcoin network. So because of this, the Bitcoin network is consuming a lot of energy, and because all computers are competing to solve this problem, virtually all of them expend this amount of energy, and this energy is too much. In fact, according to what I have here, in a study at Cambridge University, the researchers determined that Bitcoin consumes about 121 as of 2021, consumes about 121.36 terawatts per year. This is very crazy. The Bitcoin network only, we've not talked of the Ethereum network, we've not talked of any other blockchain network, but the Bitcoin network only consumes 1.36 terawatt hour per year. This is bigger than what Argentina consumes. Argentina is just consuming 121, and Netherlands is consuming 108. A whole nation. Bitcoin is consuming far more electrical energy than nations are consuming. So this is crazy, and this is alarming. And of course, in fact, according to another statistic we have here, according to Digiconomics, it says that one Bitcoin transaction requires about 700. I don't know if you can see. Let me just clean it down. Okay, I can put it here. About 700 and 7.6 kilowatt hour. I mean, according to what I have here, one Bitcoin transaction takes about 707.6 kilowatt hour of electrical energy. The amount that one US household consumes in 24 days. The amount that an average US house consumes in 24 days is what one Bitcoin transaction is consuming. And of course, Bitcoin processes about 4.6 transactions in 1 second. You can imagine, I mean, Bitcoin has consumed the power of over 4 households in 24 days, in a month, in just a second. This is very, very crazy. Very, very crazy. And of course, because of this high energy consumption, it's too expensive for them to pay for renewable energy. Renewable energy that can provide this, it's going to be very, very crazily expensive. Because the breakthrough, as at 2021 now, the breakthrough in renewable energy it's not that it's not hasn't gone so far, especially in terms of being able to provide a very large amount of energy. So we need energy that can provide this. It's going to be super expensive. So because of that, the miners, the owners of these computers that are connected to the nodes, the owners of the nodes cannot most likely afford to run on renewable energy. If this is what can be consumed in just one transaction, they cannot afford to do that. Therefore, they want to look into use of coal, fossil fuels, and all that is depleting the environment. But they feel they have no choice to do that. So they are done to do that because of the cost of running the Bitcoin transaction. So because of this, it's a very big problem, and this is even one of the reasons why the government is always. This is one of the major reasons the government is always using against the Bitcoin and perhaps the blockchain technology. That look, the energy consumption is too much, and wait that, and this is one of the reasons why Elon Musk added that to it, saying unless Bitcoin miners can find another way and all that. But the energy consumption is really high. Really high. I love the Bitcoin network so much. I love Bitcoin. But let's call it spade a spade. The energy consumption is just crazy and too much. And of course, like I said, this is because of the proof of work consensus algorithm. Because in proof of work, all the computers are competing to solve the problem, meaning they are using a lot of energy to solve the problem. Okay, so but Generation 3 blockchains are working on solving this energy consumption problem also. Because imagine as at now when Bitcoin has not really gained so much adoption, one transaction is consuming the power that a household will consume in 24 days. Then when Bitcoin gets massive adoption and the rest, difficulty level of the algorithm increases, then it's going to be very crazy. So this is a very big issue also for the Generation 1 and Generation 2 blockchain technologies. Of course, Ethereum also currently uses proof of work consensus algorithm. Okay, but ETH2 is on its way. So we've been saying Generation 3, Generation 3, Generation 3. Let's now dive into Generation 3 and see what we have.